Today's webinar will cover many aspects of the bridge and bridge repair industry. Our intention is to have these presentations not only to inform you all of what jobs and applications have been performed in the industry, but to show you all the information that's available to you. Bridge repairs and applications are more complex than other processes. Contractors have to implement a gamut of safety regulations through the EPA, local and state regulators covering the dust and how they're going to be managed, lead-based and contaminated coatings, environmental hazards, encapsulation, and blasting methodology and its processes for recovery, the handling and the disposal of the spent media. Areas that we'll be covering will be repair, corrosion protection, preservation, and cleaning solutions for bridge management. These will include paint removal, lead abatement, stone and masonry cleaning. No matter what type of structure, we can identify with the issues that they would have. The RTA and road services in your state have and identify a lot of the issues associated with the size and type of structure, and identifying environmental hazards associated with performing preservation work on any structure using sponge jet. Not only a lot of bridge maintenance would be performed by mechanical, not a lot of bridge maintenance would be performed by mechanical processes, which is hand tooling. There would be occasions that they would be used. I would expect that only for small spot areas, and normally abrasive blasting is the preferred process due to its speed and the production, and more importantly the processes is usually specified by the coatings manufacturer. Applications of specialty nature includes cable inspection. It can be blasted with no damage to the wires, spot blasting with little dust and simple containment, excellent chloride removal, repairs to prepare fairing surfaces, nuts and bolts, and other uncoated field assemble items to proper surface preparation standards. And I may use the term fairing in a couple of the case studies. Fairing is, or the meaning of it, is fairing surface is one of the surfaces that are in contact at a joint. Fairing surfaces may be connected to each other by bolts or rivets or adhesives or by welding. Rather than go through a lot of information across Australia, I've searched for information in one state alone, and I've chosen Victoria. I searched Vic Roads Bridge asset information and was able to find out an amazing amount of information. If you would like to make a note to contact your state roads authority and ask for the persons to speak to in relation to bridge restoration and preservation for abrasive blasting for coating purposes. As an example, I was able to find the following information. There's 4,990 major structures on Victoria's arterial road network. The value is $3.44 billion, and rehabilitation on these bridges over the 7-year period has been $22 million per annum. New bridges are continually added to the inventory as major new road projects are completed. For example, in the last 2-year period, 108 new structures have been completed or in progress on major projects around Victoria. The breakup of bridges by material, the structure itself, I see the breakup as being concrete at 79%, steel at 17%, and timber at 2%. Masonry and other structures are at 2% also. The interesting thing here is irrespective of the substrate type, the sponge jet can perform 100% on all of these surfaces. Bridges by class, see the breakup on highways is 56%, main roads at 30%, tourist roads at 7%, and all the others formulate 1%. Bridges by features, see the breakup as waterways at 75%, railways at 10%, pedestrian crossings at 3%, And to analyse Australia as a whole would be not representative for your particular state, but taking the information I've just shown over the last 3 tiles, it breaks down to say that there's 4,990 bridges, 75% of them are over water, 56% of them are highways and freeways, and 17% being steel. And that steel structure, or those steel structures, would suffer from more issues by way of corrosion compared to concrete structures, and our focus should be on that 17% or on steel structures. These case studies and brochures are created to offer your clients some general information about the jobs that have been performed here in Australia and overseas. The case studies will be in a usual format and offer you information that you can present to your client, offering details about the job, how it was performed, what was involved, the equipment used, what media they used, how much media was consumed, and the time taken to perform the job or application. All the necessary items for you to show your client and hopefully answer some of the important questions they may ask. As mentioned in the power industry webinar, you might remember that we're not trying to be the expert, we're not trying to be the contractor, but our equipment and media has performed these applications hundreds of times around the world with outstanding success. So here's the first case study. Project 108. It's a handrail restoration on a Truss bridge, 600 metres in length. The bridge is a major thoroughfare for traffic, biking and walking, and has about 45,000 movements daily. The scope called for was to remove a flaking paint and spot blast on visible corrosion. The substrate is steel with more than 150 linear metres of outer handrail to blast to an SA 2.5. Some pre-selected sections required an SA 3 level of cleanliness, and it was to be blasted to a 75 micron profile. Ordinary abrasives were not considered for this process, for it couldn't be performed in situ without potential hazard to the public and the traffic and the waterways from the dust and media escaping from their habitat. And we call that traditional blasting from being media. If it was, rails would have to be dismantled, taken away for the treatment, with temporary rails being installed as a precaution, and by using sponge jet they alleviated the expense of that process. So sponge jet was the chosen process for. The media used was sponge 30 grit. The unit of choice was a raspberry stream with a 35p. The setup and the footprint had to be small so that they could move the operation along as blasting and coating was performed. The contractor noted they had blasted at very low pressure to maintain the media control. They used a total of 1,500 kilograms to perform the 1,500 linear metres of the rail. Because they blasted at low pressure, they were able to recycle the media up to 14 times. And there was no square meterage stated, but from the information we can deduce that they used 1 kilogram per linear metre. They only consumed 450 kilograms for the whole process, which was their waste, and they kept 1,000 kilograms for future projects. So the consumption rate was set at 450 kilograms to do the 600 linear metres or the 1,500 linear metres. A habitat was set up on roller wheels, so it was easy to remove across the bridge or the walkway section. The footprint set up allowed the pedestrians and bikes access whilst the blasting was in process. Note the portable habitat and the public separation fence. If they were to take a moment, if we are to take a moment to look at the process of this application, the methodology can basically be adopted to any pedestrian overpass, a suspension bridge, or any structure basically that has a handrail. So if that same methodology was implemented, we could have access to a whole new set of applications. Project 1004, the Marin Centre Bridge in Ontario, Canada. The sponge jet distributor performs a lot of lead redemption projects throughout Canada. This project is a lead-based paint removal. It required a full strip and recoat on a light vehicle and pedestrian overpass on a dam site. The scope called for 100% encapsulation, and as do all lead redemption or lead abatement projects, to remove a failed lead-based paint coating system. The substrate was carbon steel with I-beam construction, and it had a light rust grade to heavy, so it was a C to a D grade of contamination, and they had to blast around 500 square metres. They required a class 3 level of cleanliness and needed to produce a 75 micron profile finish in readiness for the coating system. As you can see from the picture, the bridge is fully enclosed to run the fans to create the negative air habitat. Silver 30 was the grit that was used, and they consumed about 150 bags, and that calculates out to 2,715 kilograms to perform their 500 square metres of surface prep. That equates down to, or calculates out at 5.43 kilograms per square metre. Another unique aspect of this application was the bridge weight restrictions. It was set to a minimum of 590 kilos, including media and manpower. And this meant that other abrasive blasting processes, if they were employed, would have to stop and clean up pretty well every hour because of the weight on the bridge itself, and it would become very labour intensive. The project finished on time. As expected, the equipment used was a BVAC and also a 400 HP and 35P recycler. With the BVAC it made more simple the recovery process. Project 914. The bridge is in a residential area and had a failing lead-based paint coating system, especially on flaying surfaces on the structure. Each girder had 4 bolt joints. Each joint had 94 bolts and an additional 12 bolts at each end of the bridge structure, which increases the degree of difficulty in blasting, and productivity usually goes out the window when you're blasting some of these bolt sections. To add to the difficulty of this project, it was set up for lead redemption or lead abatement. Although the pictures don't show the complexity of the shape of the bridge, it did have a curve in it, and this added to the degree of the difficulty in setting up at the same time. The project required some 870 square metres of surface area to be blasted to a SA 2.5 and required a 50 to 75 micron profile. The inset picture is of the bolt joint or fang joint. The equipment used was a dual nozzle 100 HP hopper setup. It's like a mini BVAC with 2 hoppers, and the silo storage has a splitter on it to obviously equal out the media on return that's required to fill up the hoppers for blasting. The project used 300 bags of media. That's 5,430 kilos to complete 870 square metres. That makes the calculations pretty high at 6.24 kilos per square metre, and there's reasons for that too, which I'll go into. The external hoarding is also covered with sound deadening sheet to suppress the decibel levels. Inside the encapsulation was running about 120 dB, and outside the encapsulation was down to 75 to 80 decibels. The removal rate, the production rate, is evident throughout the whole project. In my assessment, they chose to use insufficient air, which they had 264 CFM compressor using a number 8 nozzle, and we all know that 286 CFM is required to run a number 8 nozzle at 80 psi, plus you need some reserve air, and that's why we recommend the 400 CFM. They effectively had 2 nozzles running off a 264 CFM compressor, which is why the information shows the productivity to be quite poor as far as square meterage and also for the use of the media. As I outlined in the project as well, which is the details on the tiles, it was taking them, or took them 30 days in total. 20 days of that was blasting the 870 square metres. Using 2 nozzles, and that calculates out to about 21.75 square metres per day, with a whopping 6.24 kilos per square metre. So not a really good job. If they used a 900 CFM compressor, they would have produced at least 7.5 square metres, which is double what they got per hour, doubling the production. And the important thing to take away from a project like this when we get the information, that if the contractor doesn't use sufficient air to effectively run the nozzle requirements, the project will suffer. It will show very poor production, and this will mean that the client may never use sponge blasting again. So it's very important that plant owner or site owner and the contractor understand that they've got to run a number 8 nozzle. It's got nothing to do with our equipment or organic equipment. It's about running sufficient air for that nozzle. And after shots on the bolt joints, as you can see, they're pretty intense with their bolt systems on that frame joint. Inside the end beam sections, there's only 12 bolts here to be blasted. Over the back sides there you can see them all, but there's still a fair amount of square meterage to be performed inside those areas. Note that the beams are 840 millimetres high, and they have a 140 millimetre edge on them. If we add that up in the total circumference without including the top plate, it's 2.140 square metres for every linear metre that they perform blasting for. So it's a fair amount of square meterage involved. We insert pictures of the blasting of the bolts, and the large picture is the finished coating system. Project 917. This bridge is a freeway overpass. It's situated in the CBD, and it's placed over a car park. All the work had to be performed with care so that no damage was put towards the vehicles by the way of dust and contaminants. There was 228 square metres of sponge blasting in total. That included both ends of the expansion joint. The cross-section here shows the area to be treated from the top of the concrete pylon to the underside of the roadway. This job scope here was to remove failing lead-based paint system. This meant that the habitat had to be constructed to hold 100% of the dust. Along with this, they had to, so they were required to use suppression material to deaden the dB noise levels down again to 85, and they used the same material that they did on the last job. The picture on the right is of the humpy built to house the equipment, and the blast hopper and the recycler were down below, and the yellow chute that's pictured there on the left is how they return the media from the habitat to the blasting or to the recycler. Simple way, but very effective. The bridge itself is constructed of steel. The contractor had to remove 400 to 800 microns of lead-based paint back to bare metal with a cleanliness level of SA2.5 and a profile between 50 and 80 microns. Something to note, any habitat that is constructed for lead redemption or lead abatement is usually confined space, regulated under a permit to work. This requires draft and air movement according to most regulations or regulatory authorities around the world. The equipment used on this project was 100 HP and a 35p. They chose to use 2 different medias in application. A 30 to remove the heavy corrosion and thick paint, and then reblast the area again with 80 grit. They believe it was a faster way to perform the application. I have an opinion on it. In my opinion, if they used 60 grit straight up, would have been aggressive enough to cut through all the heavy corrosion and the coating and also the rust and scale that was there, and leave the required profile for overcoating, eliminating the need to reblast the 228 square metres twice. Would have sped up the whole process. But before and after shots, which is always impressive when showing the customer the original state of the steelwork. In this one, it was indeed a rusty mess. After a few shots, after the shot, the after shot is a statement, and it basically says that we can have that blast clean to the desired surface finishing requirements with sponge jet. Project 965. Southern Cross Boat Works in Florida, USA, was the contractor that won the project, and it was to remove the graffiti off pylons on some of the major freeways. And then they had to coat them, or the job scope was to coat them with an anti-graffiti coating. The scope was to remove the spray paint or the graffiti with no appreciable damage to the concrete structure or substrate. If chemical stripping was introduced, there's no way that they could perform a wash down and contain the runoff for chemical residues, so the contractor put forward sponge jet as the process. It was accepted, and they used a one grit to remove the graffiti. The before and during blasting processes, you'll see on the left there the starting and the patch that they've done on the right side. They close up the blasted surface. The finished application showing the full removal of the graffiti off the pylon. Project 918, the Hosohara Bridge in Girder, Japan. This is on a main highway arterial that leads to a famous shrine, so it gets a lot of traffic all day long and over the weekends. The job scope was to remove a failing lead-based paint system again, back to bare metal, and reapply a new coating system. The project required underslung scaffold, as pictured. The walls were plywood to assist in full encapsulation of the bridge. The substrate was steel, and there was 832 square metres of area to blast, and required an SA 2.5 level of cleanliness, and to be profiled up to 80 microns or 3.2 mil. Excuse me. All the equipment was set up on adjoining roadside to the structure. The recovery and recycling process was performed there as well. They used silver sponge media 30 and consumed 150 bags. That's 2,175 kilos to perform 832 square metres, and they're calculated back to 3.26 kilos per square metre. They offered a removal rate on this project of 6.4 square metres per hour, and when we do the calculations on that to blast 832 square metres, that shows us that it took them 130 hours, around 21 6-hour blast days. Judging by the picture, the steel sections were quite large. I would say they're between 1200 and 1400 millimetres. That offer them a good blast runs, and this was reflected in the production that they achieved. The habitat worked well, low exposure to the workers, and completed the application on their estimated times. Some of the before and after shots of the cross members, and below the main support beams after blasting and before coating. The before painting shots and the DFT recording after they recoated the structure. Project 1015. the Longfellow Granite Stone Restoration Project on a city icon. I've actually been across that when I went over in the States. Sponge deck was used to restore the Longfellow Bridge in Boston, USA. It's a major arterial that goes out to Cambridge, and any inconvenience or interruption to the public had to be kept to a minimum for the length of the project. In the summer of 2013, the work started on this $255 million project to replace structural elements and restore the bridge's historical character. Sponge and abrasive blasting system was chosen by United Stone, the contractor. They won the bid to clean the large granite blocks on the large scale granite restoration project included on-site blasting as well as the dismantling of the iconic Lockport granite towers piece by piece, and then they were transported to nearby workyards in Charleston via a barge for cleaning and restoration. Another angle of the bridge of the before and after pictures. This video shows the blasting returning the stone back to its original finish. The Longfellow Bridge underwent a small restoration in 1959, and the scale of that is nothing to the scale of this new restoration. I mean, that was 53 or 57 years ago, and now that it's gone under full restoration, the granite has returned back to its original colour, which they call salt and pepper. There was no appreciable damage to the blasting on the granite. As you can see, that it's removed pretty well everything off there. We get the idea on that one. Once the tower's slabs had reached the workyard, they were blast cleaned with silver 80 to remove the graffiti, any dirt, efflorescence, and the environmental contaminants and that had accumulated over 110 years since their original installation. The inset picture is of the test area performed by the contractor. The setup of the equipment was inside the tunnel of the bridge structure. We kept it out of the weather and didn't expose it to rain. United Stone was able to achieve the desired cleanliness / finish on the granite while maintaining production speeds of up to 27 square metres per hour, or that was about 5 square feet per minute. Sustaining the cleaning rate was pretty critical to return the massive blocks for reinstallation, which they achieved all of this with one blaster and the one system being on one hopper and one recycler. Sponge was chosen as the method for the restoration for a number of reasons, and Jeff Hartwell, which is the VP of Operations for United Stone, said that the sponge jet system had worked great for us on the Longfellow Bridge and other projects. Once the setup is in place, the system can do its job with a two-man crew. You can't say enough about the eco-friendly aspect of sponge blast media. All in all, you would have to force us to go back to acidic cleaners or bucket and brush cleaning. Project 910, John Holland Wharf and Jetty project, and you've seen this a couple of times, but although it is a wharf and jetty project, it's not really classified as a bridge. The setup is exactly the same process, and the application is pretty much the same as a bridge. We can present the case study on a large scale as a case study for a large scale project for overwater abrasive blasting, and it required thousands of square metres to be blasted. The inset pictures of the existing wharf so the client can see how large the new project will be, because it will be 4 kilometres long as well. The infrastructure around that will be exactly the same as the bridge. You'll have traffic conditions, other conditions. In this case we've got loaders and people and types of things around it. Something important to remember and emphasise when talking to clients is that this project was won over Garnet. So we were up against Garnet before we started. We presented the issues back to the client that no matter how much they encapsulated with Garnet, the pink dust still goes everywhere. The surrounding areas are covered with Garnet dust. Even the encapsulation sheet and beams and pipework are all covered with Garnet dust. We presented and showed that they had the bones of the job, the scaffolding already in place, so all they have to do is set it up for sponge jet and look at doing that process. We pointed out to them that they were always having problems with any abrasive blasting over water, and to get Garnet out there, the mobilisation and demo, I explained that if they were set up with Garnet, the project would have delivered 220 tonnes of media onto the project to recover it, and at the same time they had to demob the Garnet and dispose of the spent media as well. And it showed that we showed them that there was savings of $180,000 worth of savings by changing over to sponge blasting on the same project. Once a habitat had been constructed, all the blasting and coating requirements can be performed inside the same habitat. There's no need to remove and rebuild it for a coating process. A picture is a good message. If they can see what the setup is like, then there's no reason why they can't duplicate the process. With 4 kilometres of loading wharf to build, paint and blast, it's quite a sizable project to compare it to a bridge. One very important feature was the amount of actual media consumed on the project. There was 16 tonne of sponge media consumed. They expected to use, or a consumption rate of Garnet was estimated at 220 to 240 tonnes. So it's a pretty good comparison. In this short presentation, I'd like to show you what's involved with performing a bridge application. For a contractor to successfully quote for a bridge project, they will have to have a fair amount of information that's relative to the environmental surrounds of the structure, the preventative means they intend to put into place to reduce the risks of potential hazard. The inset photo is of a bridge that's set up for lead redemption or abatement, and there is no need, there is a need for scaffold and 100% encapsulation. Using a blast sheet, this may also need to be fire retardant grade, and it needs sufficient airflow as cross-draft and downdraft as outlined in the Australian standards for design recommendations. To further the requirements, there needs to be adequate ducting and ducting system to go back to a huge commercial dust extraction fan. You can see the duct there on the right-hand side of the photo in red. The fan systems are required to purchase outright for $250,000, or they can be hired. That is, what you get is a 40,000 CFM extraction fan. The exhaust air has to go through a HEPA filter system that extracts out the dust particles down to 10 microns of respiratory dust, and that size allows it to go back into atmosphere without endangerment to the individuals or the public. These units draw a huge amount of power for the vacuum system, and it's also has to be partnered with a generator, usually diesel, which adds to the overall cost of the setting up. To add to the 40,000 CFM extraction fan unit, there needs to be an incredible amount of pipework to accompany the extraction system. One side of the air is feeding the habitat and the other side is extracting the dusty and contaminated air back to the filter system. The items I've mentioned so far are only to do with the air extraction to remove potential hazards out of the habitat. And in most cases, and not all, there will be a support barge set up to control the volumes of waste. There will be a person in the habitat moving the garnet to a particular spot to gravity feed it to an outlet in the habitat, and then it's transferred down to bins or drums for collection. This media may be used again, but usually not on the same project. Depending on the volumes of garnet required to perform the project, will reflect greatly in how many times those bins have to be emptied. Picture of the bins and drums to store the garnet for disposal. This also has to be manned with a dedicated person or employee to manage the process. The storage yards set up around the equipment houses the extraction equipment, the blast hoppers, the air prep unit, the generators, the bulk media, vehicles and items stored for the project. Sometimes it's not enough room to house all the items that are needed. The roadways have to get blocked off, safety barriers put in place, and that's before any abrasive blasting is performed. Why have I showed you all this information? It's my belief that we can reduce the footprint and expense in setting up the environment to perform abrasive blasting and surface preparation on bridge structures. There are necessary processes and procedures that have to be adhered to. The need for scaffold, we need the same habitat built to establish a negative air and ventilate habitat, but would we need 40,000 CFM of air movement to create 30 cube metres of per minute of cross draft? I don't think so. It's I don't think it's necessary. Under the Australian Standards 43611, as detailed, we have the responsibility to minimise the amount of exposure by creating mechanical ventilation. It's all about exposure of lead, which enters our blood system if we were in there, through the skin and our respiratory systems. The volumes of air create flow greater than static pressure, thus reducing the exposure to personnel. When we're looking at the information that's on offer to us through SpongeJet HQ, they have performed tests in these environments and they've made the results into a very simple chart. Anyone can look and make some simple observations here. The first one is that the product relates to sand. The dust and processes between sand blasting and garnet blasting are pretty much the same. Sand shatters and creates dust at the substrate, identical to garnet. Second observation is that there will be a total lack of measurable airborne lead concentration when blasting with SpongeJet. The graph shows the dust exposure to the blaster operator and an air monitor in the environment as outlined and highlighted in the highlighted section. SpongeJet blasting reduced the airborne lead concentrations by over 90%. So it's 90% less than they would have with traditional blasting on the area monitor and the operator. That's 90% less airborne lead. The question is, will we need the same amount of air volume dust extraction as garnet system? If we're using a BVAC unit, it has a significant benefit over a garnet blasting. A garnet blasting environment, as it returns the media back to the system cyclonically, removes a greater amount of aspirated coatings and dust and the lead and puts it into the waste. Recycles the media automatically, refills the hopper and it's ready to continue its blasting process. And that's without being handled by an individual. There's no exposure in that process from recovery through back to blasting. Plus the overall weight of the media on the scaffold is reduced by hundreds of kilograms, all with one very small footprint, which is the BVAC size. There will be a need for some air movement, but I don't think at the volume that we'd be working under normal working circumstances. We have a pending project with Headstock coming up in August on a bridge application in Sydney. which is a lead-based paint removal, and we'll be working closely with them to monitor all the requirements, what we do know the minimum, and what our maximum requirement is at the same time. Project 1011. It's a simple project. It's an overwater facility in the Pilbara region in WA. This was actually performed with sponge deck by IAS in WA. The project is suffering from long-term exposure to coastal and seaside conditions. There is evident heavy corrosion and severe pitting to the steel structure. The project also had a weight restriction that had to be adhered to, and that is not exceeding 13.6 tonnes per 25 metre span. The structure was predominantly steel. The scope is to restore it back to its original condition. The project is to perform 1,500 square metres of lead-based paint removal and surface preparation through class 2.5 and a level 2.5 level of cleanliness with a 50 micron profile. The media selected originally was an 80 grit to suit the 50 micron profile requirement, but they found after the process had started that Silver 60 was a better option. It allowed for better production, and it was leaving a larger, although it was leaving a larger profile, the speed and the removal rate increased dramatically, which outweighed the extra micron profiles that they had. The project used 353 bags of media. That's 4,800 kilograms, and that equates to 3.2 kilograms per square metre. The equipment used was a BVAC, fully automated blast and recovery system. For the same purposes they use that on the job as I've just explained in the case study before this. And there's far less exposure to contaminated media, and the BVAC's recycling system is enclosed and automated, and there's just less exposure to everybody in that process and in the blasting area themselves. As you can see by the pictures, there's extreme corrosion on top of the pylons and the headstocks, which are the little crossbeams. Needle guns were used to remove the excessive corrosion and scale that was evident throughout the project. This was performed prior to all the blasting applications. It was then cleaned down and removed from the habitat, so the recyclability and cleanliness of the media mix was maintained. As the picture shows, the habitat and surrounding areas were set up in readiness for the sponge blasting process to start. And that is one 25 metre section that's pictured there. The project allowed for inspectors to enter the habitat with PPE to minimise any unnecessary exposure from the lead paint. Safety netting was also a requirement for the personnel's OH&S requirements on the job. And the picture in the bottom right is the setup of the sponge jet blasting equipment on a flatbed truck. That allowed it to be driven out onto the wharf structure to connect up to the blasting hoses that remained in the habitat, allowing them to demob and on a daily basis, and that was necessary for those other trucks there working at night time. Some of the information that we can supply to clients is about magazine articles. This one being the Storebaelt suspension bridge. It's a joint venture project between BCM and ESL, which are an engineering company in the UK. They joined forces with over 100 staff members to weld together 57 bridge sections back in 1997. This was innovative and a new type of application, and the British firm Global Project were responsible for the painting and weld joints, the painting of the weld joints, and introduced sponge jet as the process to perform the surface preparation. The article doesn't have much substance, but does state that the project used sponge jet as a surface preparation system. And this is what the article looks like, and I think most of those are in the info pack that we can supply to you, similar to what we did in the power industry. This brings the webinar to a close, so that's all I've got for you in relationship to bridges. Tess, if you could cut off the recording, and we'll go to our question time.
Yep, okay.